Do you become a multi-planet civilization or not? And if you don't, it's simply a matter of time before something happens on your planet.
The billion-dollar telescope is the largest and most powerful in space. It captured these images.
The James Webb Telescope has been providing us with spectacular images from space for 2 years now. While the most powerful space telescope of all time has been peering into the deepest and oldest secrets of the cosmos, it has not only provided astronomers with many groundbreaking insights, but also a number of tantalizing mysteries. How can it be that galaxies are slumbering out there, which, according to our understanding, should not exist at all? Why does the value of the Hubble constant measured by Webb, which describes the expansion rate of the universe, simply not match our current models? These are questions to which experts are currently desperately searching for answers. Fortunately, the James Webb Telescope is not only capable of uncovering the most baffling mysteries of space but also its overwhelming, almost frightening beauty, which regularly reminds us how small we are in the grand scheme of things. Humans like to describe themselves as the crown of creation. Whether we want to accept this not exactly modest title is, of course, up to each of us to decide for ourselves. But when it comes to the question of the most impressive creators of the universe, it is clear who deserves the honor. But before we get it wrong, the James Webb Telescope has, of course, not uncovered some ominous power that created the cosmos, but together with Hubble, has provided an unprecedented combined view of the pillars of creation, which are among the most famous photo motifs in modern space exploration. Some 7,000 light-years away from us in the open star cluster of the Eagle Nebula, we are looking at the glowing pillars of a stellar cradle, captured for the first time by the Hubble Space Telescope. Basically, stellar life begins in dense, cool clouds of gas and dust. When the gas clumps collapse under their own gravity, a protostar is formed first, which attracts matter from its immediate surroundings. And as soon as the sparkling offspring has built up enough mass, it can ignite the hydrogen fusion in its interior and become a real star. However, stars often do not develop on their own but in collective alliances such as the pillars of creation. While the Hubble Cosmic Snapshot from 1995 still shows the overwhelming structure in the visible wave range, the James Webb Telescope took a look at it in the infrared. The combination of these two images ultimately gives us completely new insights into this structure, whose finger-like outgrowths are even larger than our entire solar system. While countless newborn protostars and stars lie dormant in the dusty Cumulus cocoons, their intense radiation and stellar winds have blown gaping holes into the dust cloud shells, giving them an unmistakable appearance. Given this breathtaking sight, it's no wonder that the pillars of creation were among the first subjects of the James Webb Telescope in 2022. But now NASA has combined the Hubble and Webb images to reveal even more details. While the infrared images reveal the stellar babies and cool gas components, the visible light presents the scorching hot glowing gases of the star forge. The bottom line is that the spectacle is not only available as a photo but also as a video. If you watch the corresponding clip, you will be treated to an exciting flight through the three-dimensional pillars of creation. In the course of this, the view switches between visible and infrared light, proving once again why it is so important to explore the different aspects of one and the same structure with more than one space telescope. The stellar family portrait is no less fascinating than the combined view of the pillars of creation. The family photo that Webb recently snapped in the Serpens Nebula, 1,300 light-years away, is particularly striking. In detail, we are also dealing here with a stellar nursery, more precisely with a so-called reflection nebula, which produces no light of its own but is illuminated solely by the light of the stars in its interior and vicinity. For the telescopes of the past, the nebulae were often still insurmountable optical barriers. But Webb's NIRCam is able to penetrate the dust and gas compounds to a certain degree, and thus make visible those things that have eluded our research vision for so long. While the gas and dust in the images are a vibrant orange, red, and blue, we can also see the intense sparkle of the countless young stars. Some of these dazzlingly bright celestial bodies are just 100,000 years old, which means they are still in their infancy in astronomical terms, and yet one day they will have the mass of our Sun. The bottom line is that one detail of the star family portrait is particularly striking: the flame-like structures at the top left of the image, which are reminiscent of colossal shreds. These are the traces of gas and radiation outflows from young stars, which appeared in earlier images in visible light either as blurred spots or even completely invisible. NASA compares these protostellar outflows to sleet falling from the sky during a strong storm. This is the first image to show that the outflows all point in the same direction. But what for us are merely structures moving from top left to bottom right on the images are an important research indication for the experts. After all, this image evidence supports the assumption that young stars tend to rotate in the same direction when their gaseous birth envelopes collapse. But what's the story behind the black bars at the bottom left and top right of the image? Has NASA applied the sensor pen here to make one or two UFOs unrecognizable? Well, unfortunately, it's not quite that exciting. The black rectangles simply indicate missing data. The first photo of the superjupiter, 6,911 exoplanets in 4,941 systems. The number of known planetary worlds orbiting a host star other than the Sun is growing practically by the day. Researchers have already added some unusual celestial bodies to the star maps as part of the planet hunt. So far, these include, for example, the gas giant HD 189733b, which is only 63 light-years away and, according to the latest findings, smells like rotten eggs. What initially sounds rather strange or amusing is actually the first evidence of hydrogen sulfide on an extrasolar planet. Apart from this, the experts have also proved to have the right nose in other areas. We now know of a whole series of nearby exoplanets, some of which are Earth-sized and even potentially life-friendly. In this regard, K218b in particular has been making headlines for several months because this celestial body is suspected of being a full-blown ocean world on which life may even have already unfolded. In detail, Webb's near-infrared spectrometer, NIRSPEC, captured some potential biosignatures here, specifically the spectral signatures of methane, carbon dioxide, and dimethyl sulfide, DMS for short. The latter is produced on Earth by marine plankton and during the decomposition of organic substances. The molecule is the main supplier of atmospheric sulfur and produces the typical marine odor. How the DMS signal on K218b is to be interpreted, however, is a completely different matter. In fact, it was not particularly pronounced in the Webb data and only revealed itself when the data sets were analyzed in a very special way. So, until the background to this exciting discovery is fully clarified, a little patience is still required. Things look a little different in the case of a snapshot that Webb took in a completely different place. Despite all the exoplanets that have already been discovered, different images of these alien worlds are still in short supply. Most images mainly show young, hot gas giants, as these appear as comparatively bright spots on the light in the infrared. But there is a much cooler way. A few weeks ago, Elizabeth Matthews and her team from the Max Planck Institute for Astronomy in Heidelberg succeeded for the first time in making a cold, older exoplanet directly visible. The foundation for the image was laid by studying the triple star system Epsilon Indi, which is located just 12 light-years away from us. While the cosmic trio is made up of two brown dwarfs and the orange dwarf star Epsilon Indi A, earlier spectral analysis had already indicated the existence of a large planetary companion. An analysis with Webb's MIRI spectrograph later revealed that the system did indeed harbor an exoplanet, but it was in a completely different location than earlier studies had suggested. The simple reason for this was that the previous studies had hopelessly underestimated the mass and orbit of this giant gas planet. The bottom line is that we are dealing here with a celestial body that can confidently be described as a superjupiter. We remember, as the largest member of our planetary system, Jupiter has a diameter of around 140,000 kilometers and a mass of 318 Earth masses. However, the bright point of light that the experts detected in the images of Epsilon Indi is probably 6 times the mass of our Jupiter. Christened Epsilon Indi AB, the extrasolar colossus orbits the main star Epsilon Indi A in a relatively eccentric orbit, the greatest distance of which corresponds approximately to the distance between the Sun and Neptune. As a result of this constellation, Super-Jupiter takes a whopping 200 years to complete a full orbit. It was, in fact, this eccentric orbit that explained the surprising deviations in earlier observations. They had actually detected the planet at the closest point to the star in its orbit, and, in the same breath, incorrectly located it in a circular orbit. However, the new analysis was not only accompanied by an orbit correction but also revealed some of the exoplanet's characteristics. For example, the thermometer here drops to around 0 degrees Celsius on average. With an age of around 3.5 billion years, the gas giant is truly no longer a planetary youngster. Of the 25 or so exoplanets directly imaged so far, all were less than 500 million years old, and the majority had less than 100 million years under their belt. Against this background, Epsilon Indi AB is therefore not only the coldest but also by far the oldest exoplanet that has been directly imaged to date. The corresponding images are, of course, not only beautiful to look at for the scientists, but they also hold huge potential for gaining new insights. For example, age exoplanets of this kind are ideal for putting our models of planetary development to the test and gathering new information about the later stages of extrasolar worlds. At the same time, however, Epsilon Indi AB still holds a few mysteries in store. It appears that parts of its radiation in the shorter wavelength range are literally being swallowed up. There may be clouds in the gas giant's atmosphere that are responsible for absorbing the infrared radiation, although chemical compounds such as methane, carbon dioxide, and carbon monoxide are also possible causes. Conveniently, the experts are already planning to investigate the consequences, and provided nothing unforeseen happens, the true reasons for the suppressed radiation flux will soon be clarified. Speaking of suppression, you are now welcome to press the button below our video to boost the subscription flow. So, join our community now and never miss an exciting video from us again.